Deep learning is a powerful tool in modern data science that enables machines to learn and make predictions from large data sets. Convolutional neural networks and recurrent neural networks are two popular neural network architectures used for image and sequential data analysis, respectively. In this video, we'll introduce these concepts through easy to understand Python code examples, helping you grasp the fundamentals of CNNs and RNNs for your data analysis project. So let's get started with understanding what is convolutional neural network. Basically, a convolutional neural network is a type of neural network designed for image recognition task. It processes images by using convolutional layers which are inspired by the structure of visual cortex in the brain. A convolutional layer applies a set of filters to the input image which helps extract important features like edges, shapes, and patterns. These filters slide over the image, performing a dot product with the image pixel and applying an activation function, say ReLU, to produce a feature map. Now, these feature maps capture increasingly complex features at different locations in the image, and this convolutional neural network typically include multiple convolutional layers followed by pooling layers, say max pooling for downsampling and reducing the spatial dimensions of the feature maps. And this process helps to reduce computational complexity and maintain important features. So after one or more convolutional and pooling layers, the image is flattened into one-dimensional vector and one or more fully connected or dense layers are applied to process the flattened feature representation and make predictions. So to summarize this, we can say convolutional neural network is a neural network that uses convolutional layers to process images, extracting important features and then process these features with fully connected layers to make prediction. Next comes a Python code to implement CNN. So here is a simple example of how to implement a convolutional neural network in Python using the Keras library. First, install the Keras and its dependencies, then create a simple CNN model using this code. So this example creates a simple CNN with two convolutional layers, each followed by a max pooling layer. It then flattens the output and adds two fully connected layers. Here, the input shape parameter in the first con2D layer specifies the shape of input images, that is 64 into 64 into 3 for RGB images. Now, dense layer has 64 and 10 neurons respectively, with output layer using softmax activation function for multi-class classification problem. And this is just a basic example to help you get started with CNNs in Python using Keras. To train and evaluate the model, you will need to provide your own dataset and training code. Then comes recurrent neural network. Now, this recurrent neural network are a type of neural network designed to process sequential data such as time series, speech, or text data. They are called recurrent because they have recurrent connections, allowing information from previous steps to be carried forward and influencing the current steps computation. In recurrent neural network, the same set of weights is applied at each time step, allowing the network to maintain a memory of the input sequence, and this memory is updated with each new input element, allowing the network to process the sequence one element at a time while maintaining a context of the entire sequence. And the most common type of recurrent neural network is a long short-term memory network, where the LSTM or the long short-term memory networks are designed to handle the vanishing gradient problem, which occurs when training deep recurrent neural networks with long sequences. Now here LSTMs use a clever gating mechanism to selectively forget parts of the memory, update the memory and output the relevant information at each time step. So to summarize this, we can say recurrent neural network is a neural network that processes sequential data by maintaining a memory of previous inputs, allowing it to handle dependencies in the sequence and make predictions based on the entire sequence. LSTM are a type of recurrent neural network that are particularly effective at handling long-term dependencies. Now comes the Python code. So here is a simple example of how to implement a recurrent neural network in Python using the Keras library. First, we'll install Keras and its dependencies. Then we'll create a simple RNN model using this code. So this example creates a simple RNN with one LSTM layer having 32 units. Here, the input shape is defined as 101, representing a sequence of 100 time steps with one feature each. The output layer has 10 neurons and the softmax activation function is used for multi-class classification problems. Thank you.